Hi, my name is Krista Daigle, and I did my project on tall buildings, and it's about finding the best structural design when it comes to earthquakes. So what I did when doing this project is that I had to construct a springboard, and that's this right here, and I did this by the help of my neighbor Scott Henry, and that's him up there in the picture. He's a carpenter, and he was a big help. When doing this experiment, I had the help of my science teacher, Mr. West, and that's him in the picture. He was my supervisor while I was in my school's physics lab, while I was using my school's technology. How I did this experiment was that I had two motion sensors hooked up to my towers. I had one hooked up to the front side of the building, measuring the front to back motion, and one hooked up to the side of the building, measuring the side to side motion. I did this experiment with the help of my father, Lawrence Daigle, because the forces were too strong for me to hold and I needed a steady hand. So how we did the experiment was that you pull back on the force meter and wait till the motion was out of the building, and then you'd click start on the computers and then let it go. And then all these different types of graphs would come up on the computer. I used 4 different forces, and for each force I did 3 different trials. And that was because the motion sensors are really sensitive and can even pick up dust particles. So for each graph I got the average maximum and minimum, and I subtracted the two and got the difference, and the difference was its actual displacement. Overall, Tower 2 did the best, and that's this structure here, and that was because it had more flexibility than the other 2 towers. So when the force was applied, the building was flexible enough to absorb that shock wave and the aftershock.